Well, if I had the information going into a structure fire, a building fire, that I knew the building codes were actually being followed, so better building codes and mandatory sprinklers in literally every occupied building. If I had that kind of information going in, that would definitely change my risk calculation, and it would change my deployment of resources. So while it's not strictly information, knowing that information was there about that the building codes were followed and that mandatory sprinklers were installed and inspected on a regular basis, that would definitely influence firefighter safety and improve outcomes. I mean, the sprinklers have proven their effectiveness time and time again. You know, earlier detection of fires through, you know, multiple IR sensor technologies that now exist, that would definitely help. So that earlier detection, again, the earlier you get there, you slow the growth curve, or you prevent it, you know, from even getting past that incipient stage. You know, just seeing a risk trend, such as, you know, an increase in, you know, just small levels of heating, so temperature rises and things like that start fitting profiles mixed with AI, say, hey, there's a problem here. You might want to watch this. And individual risk profiles for each structure in the jurisdiction based upon your GIS layering and your past inspections, the history of those buildings, the call history, even the utility history. You know, has there been an incredible amount of electricity used recently in what was supposed to be a vacant building? Well, right away, I'm suspicious that there's some kind of a grow operation going on, you know, if I see high spikes in electricity and nobody's supposed to be in that building. So how does that build into a risk profile that can be spotted by AI and prompt you to think of something? Past call history can be a good indicator of, you know, what's going on in that structure as well. What did you observe? But again, you have A crew that goes to it, and then B crew follows up on the actual fire, but doesn't know the information that, you know, A crew, you know, went to. So, you know, one of the other things I think about to make firefighters safer and improve outcomes would be integrated traffic control systems, which are designed to slow or completely stop traffic at the scenes of motor vehicle collisions. We still have way too many firefighters getting killed on the side of the road, and that's unacceptable as far as I'm concerned. There needs to be a real-time integration, and you know, it wasn't that long ago where we were still in some jurisdictions, and some still are arguing with the state patrol or the sheriff's department on whether they can shut a lane of the road down or not. The time for that argument's passed. If you need a lane, you shut it down. You block it with an engine and you take it. If you need two, you take two lanes, and then you deal with the consequences later. And we literally had, you know, poor communication that has resulted in fire chiefs, you know, in certain jurisdictions actually getting arrested because they said, I'm shutting this road down for my firefighter safety, and the officer didn't agree with that, and it turned into a, you know, who's in charge idea. But you know, one of the other things that could improve firefighter safety long term, and this is really taking care of our firefighters, but it would be biometric monitoring. You know, real-time monitoring for signs of stress, cardiac abnormalities, respiratory contaminants. You know, we may get to the point where you're literally looking at, you know, more than just oxygen saturation, but you're looking at levels in the bloodstream, you know, in real time. It's not too far-fetched to think that that might be entirely possible. Along with this, you know, and again, when we think about the big killers of firefighters, it's cardiac, it's cancer, and the third is, you know, is suicide. It's mental health. So in the United States, more firefighters take their own lives than actually die in the line of duty. And so mental health evaluations, taking care of our firefighters through those mental health evaluations, through those ways to evaluate how they're doing as firefighters and as caregivers in our community, that cumulative stress needs to be evaluated. They need to have outlets. They need to have support to be able to deal with some of the, I mean, we see some terrible things. Nobody should have to, and they need to be taken care of, and it should be treated as an on-the-job injury when they suffer a mental health crisis due to what they see and witness and have to deal with. So those are some ways I can think of to make firefighters safer, and through monitoring and through some technology and integration with the fire service.
Well, again, if we take a look at an emergency management scene that might involve a structure occupants, civilians, and a variety of different challenges from an operational mitigation standpoint. The one criticality there is that information has to be modular or modularized. It has to be retrievable based upon the incident parameters. So there's a lot of data that has become available over the last 20 years. The ability to access that data in a timely fashion still becomes part of that challenge due to the internal security measures and the barriers that are sometimes put in place. So the availability of whatever data that may be needed, almost having that a la carte capability. So the criticality is being to have that data in a modularized manner that's that can be built into the system based upon the incident complexities as the incident complexities either increase or stabilize. So it's difficult to say, well, I need this large amount of information for a relatively simple incident. But at the same time, the simplicity of the incidences, I think, as I elaborated or related to early on, is that most incidences today have the potential to become very complex and very challenging at best. And that's what we're seeing. We're seeing the potential for very significant incidences to occur and to extend very rapidly in a variety of different environments, whether it be the rural to the large metropolitan kinds of conditions. Now, naturally, the more complex the location of these incidences, the more likely those conditions may increase in severity, urgency, and growth, thus needing very timely data that's modularized and can be very quickly escalated up to that level. So the availability of that information really has to be made available for the most complex of conditions, but again, be able to be retrievable, accessible, and utilized for the most simplest of conditions, and also to be affordable. So, you know, in one instance, I may be relying on the need for technology to provide me with thermal capacities to allow me greater visibility within the confines of a structure that might be involved in some type of fire and smoke conditions to help locate a fire, mitigate and control it, while at the same time helping to evacuate civilians. We may need another layer of technology and support to be able to track our firefighters as they move through very complex structures, both vertically and horizontally. You know, one of the challenges is that the built environment today on a global basis is increasing with advancements, both in terms of construction as well as complexity, at such a rapid scale that the fire services, the fire departments, and the fire brigades do not and have not been able to implement the appropriate practices and methodologies, both from an operational and a management standpoint, to keep up with that. And that continues to be part of the challenges. Our built environment, the infrastructures, and those systems, those built environments, the occupancies, and the infrastructure are so reliant on technology that they've evolved into, that when we implement the emergency services side, whether it be from a large-scale disaster or a brigade or fire department response or EMS response and so forth, there's that need to be able to tie into that intelligence, that information, and be able to apply it for whatever the circumstances that incident may have. That becomes the key. That's where I think the linchpin of where we're going to go is it's got to be in small bites, but at the same time it has to be in that tetrabytes or larger capability of information based upon what I may have, whether it be that small cottage or building fire or commercial fire in a structure, all the way to a large scale disaster or a large scale terrorism related type of condition. So it's one of the same, but it's just relative to how it steps up in magnitude and severity relative to the time and what the needs may be.
Often it's okay, what are the top 10 problems? What are the things that we can make an effect on in 6 to 12 months? And which one of those should we start on first? And I kind of laugh, but not really, because it's not any one of those things. There's no couple, 2 or 3 things that would make the biggest difference. situational awareness is the basic principle of helping us make decisions.
Yep.
Who's called? Where are they? What's the problem? What are the resources that a first responder needs to mitigate that situation? Situational awareness. And when I first started, we had lots of discussion about incident command training. We need a command officer, depending on how large the incident is. We need a safety officer, a public information officer, a unified command with the other agencies that are responding, finance, logistics, operations, whole big structure. Maybe you got 10,000 personnel on one call. Much of which is done with two-way communication. And that C2 model became a C4 model, which is now a C6 ISR model. So it's command, control, computers, communication, cyber defense, intelligence, surveillance, reconnaissance. So you pick which. I mean, just teasing, but it's all important all the time. It depends on which of the 7,000 lives we're trying to save today.
Well, certainly, if I'm responding to a building or a site, the initial alarm information will have either a printout or be visible on a screen in the computer, in the apparatus on a computer screen. But I'd like to go deeper, if you want to call it deep diving. Maybe have a field on that screen where it's an icon for the building. I can touch it and maybe get a Google Earth view of the building, an aerial view, and then be able to switch that around, if you will, into a 2D or a 3D angle, so I can see how many floors it is. I mean, that information will have been static and printed out for me, but I'd like to take a look at the building and from the different sides to give me an idea where I could place apparatus, where hydrants are. In other words, all the resources I would need, and do that at a quick glance. Would also be nice if it was annotated so that anybody could just look at it and say, oh, this is what I want. Boom, I could touch on that. We're not there yet, but things like that, that would be a beginning. And that would be just a response. When I arrive at the building, at least myself, if I was an incident commander or chief, I'd like to be able to access real-time data of the building. And if we're going to talk high-rise building, or let's say a large warehouse, things like that, what I mean by real-time data, what would be the status of the HVAC system? That's heating, air conditioning, ventilation. Is it shut down? Shut down so that it's not going to feed the fire anymore, fresh air, things like that. What's the status of the elevators? Maybe access to security cameras in the stairwells. If people are evacuating, I can see if there's any bottlenecks, things like that, any issues going on there. I'd like to be able to access real-time data.
Not only being able to see the information, see what dispatch is telling us, reading the actual address again, seeing what the call's about, being able to have, I would say, like to go a little deeper and to pull a layer or two back behind and say, could we know how many times we went to that address? What type of building is it? What's room and contents? What's important in that building? I think those kind of pieces, and knowing why, you would not always have like maybe a small community like us in a small fire department where we're the same people going on those calls. But if you were down here on the highway and you weren't your A, B, or C shift, you don't really know each other's calls, since you don't know if you're going to the same place, many times to know about its history. So it'd be nice to have that. And this other piece that's really important here in America is our fire reporting system, our fire incident reporting system, INFIRS. It starts with N for national. And I would love to see that data be able to be put in while you're on the call, while you're coming back from the call, and being able for it to plug and play and go right to that system, so we don't have to go put that information in again.
Yeah. So currently, are you kind of duplicating that process with the reporting? You're having to do it twice.
Right, exactly. So, we go home, we put it in our system, but I still have to go into this other system for the national data, because it's really important to have this data. It's really important to know what type, like you said, if things are changing, structure fires, wildland fires, motor vehicle accidents, home health care, just, home community calls. So it'd be good to have it, but it'd be good if they were connected.